Hi, scientists. We've been learning so much about the properties of water. I'd like to share with you a reading about how ice is everywhere. Track along and read along as I read to you. Ice is everywhere. You probably know where to go to get some ice. Indoors, you find a refrigerator and look in the freezer. Outdoors is a different story. If it's winter and you live between Montana and Maine along the border with Canada, ice is everywhere. Every pond, creek, and bucket of water is frozen. In the warmer parts of the country and during the summer, finding ice outdoors can be a challenge. So, as I was reading this connected to our study about regions and how each region had different climates, excuse me. Some places are cold all year long. Alaska, Canada, Greenland, Iceland, Scandinavia, and Siberia have ice year round. Antarctica, which covers the South Pole, is the iciest continent. More than 95% of its land lies under thick ice. In some places, the ice is 4,300 meters thick. In the winter, frozen seawater forms an ice shelf around Antarctica, doubling the continent's size. So imagine that. The ice is enough to double the amount of land on that continent. If you live in snow country, you know what to expect. Usually, starting in December, heavy snowfalls covering everything under a white blanket. During a heavy snow year, the snow may stay on the ground until March or April. Then it melts. I'm going to read the captions here. Ice off the coast of Greenland. So, this is what you would most likely see off of looking out into the sea of away from Greenland, and polar bears on the ice in Arctic. Glaciers, header. What if the winter snow didn't melt during the summer? Think about that. In some of the colder regions around the world, more snow falls than can melt in the summer. Snow piles up and up. The layers of the snow at the bottom get compressed and turned into pure ice. When the ice is about 18 meters thick, it begins to move. Moving ice is a glacier. Glaciers are rivers of ice that gravity pulls downhill. Let's stop and take a peek at the captions and the photos here. So this is a photograph of an Alaskan glacier, and a glacier ends at the sea. I was able to go to Alaska once to run a marathon, and all around my surroundings, I saw glaciers all around me. Scientists can keep track of how fast glaciers move. An average glacier advances less than 1 meter each day. A glacier in Greenland holds the speed record. Jacob Havin Glacier is speeding along at more than 35 meters per day. So that's like a speed racer glacier compared to the other glaciers. Glaciers now cover about 10% of Earth's land. They are found in all of the world's major mountain ranges. All the ice in the world store about 65% of the world's fresh water. Now think about that. 65% of the world's fresh water is all stored in ice. If all that ice melted, sea level would rise about 79 meters. So, in other words, our oceans would get real higher if they all melted. Think about what that would do to our land. Think about what that would do to our environment, our ecosystems, habitats for animals. Would that change anything? Header. Icebergs. Icebergs are mountains of ice drifting like islands in the ocean. Icebergs are frozen fresh water, not salt water. Where does all the frozen fresh water come from? Icebergs come from glaciers. When a glacier moving down a valley reaches the sea, pieces at the end break off. These chunks of ice may be as small as cars or as big as mountains. The largest iceberg ever measured was 320 kilometers. So it's like approximately 320 miles long. So think about that. So that is, I'm thinking of an approximate measurement from here to the middle of our country. Wow, that's a lot. That's a very large iceberg floating in the ocean. We see only a small part of an iceberg. 7/8 is hidden beneath the water's surface. So that, in other words, when we learn about fractions, we're going to say that if 7/8 is below, only 1/8 is showing above. So most of the iceberg is hidden. We can't see it from the surface. Icebergs in the North Atlantic can last up to 2 years before melting. Larger icebergs in the Antarctic may last 10 years. I'm inferring that it can last 10 years because the climate in the Antarctic area is so cold. Someday, icebergs may be a useful source of fresh water. Ice could be harvested and melted. Whole icebergs might even be towed to countries needing fresh water. As a fun connection, this reminds me of the scene in Frozen when they were cutting the large chunks of ice. So here is the caption: icebergs form when pieces of ice break away from the face of a glacier. That's amazing that photo captured that falling. A large iceberg might extend a kilometer below the surface of the sea. So what you see in this picture here, I'll get my pen, we can see the tip of the iceberg, but hidden way below the surface of the ocean is most of the iceberg. We can't see. I'm thinking this is a lot like if when we're floating in water, if we're swimming, we can only see our head and then most of our body is below. Let's look at our next page. Header. Before refrigeration, header, ice history. So, I think this is going to teach me about the history of ice. Before refrigeration, people used ice to keep food cool. Ice was harvested from frozen lakes and rivers in winter. People waited until the ice was at least 60 centimeters thick. Then it was strong enough to hold the ice workers. Horses were used to plow a frozen lake to clear away the snow. Then the horses pulled a special tool that scratched lines in the ice. Workers cut along the lines with sharp saws. They used poles to push large sheets of ice to ice houses. There, they cut the sheets into smaller blocks. Ice houses looked like barns. Inside, the ice workers carefully stacked and stored the ice blocks. They spread straw or sawdust over and around each block to keep it from melting and sticking to other ice blocks. So again, I can't help but think of the scene from Frozen when they're singing together, "Hold it on the rain and mountain waves will find me." And yes, I'm singing. But this is reminding me of that. And ice workers mark lines on the frozen lakes. So can you imagine that? Before we had refrigerators, and in a way, it's kind of like a luxury today. We had electricity to keep all of our food cold and have cold water and um, ways to keep our food in good shape. Here, they would have to go and cut chunks of ice. I don't know if that would be an easy task. What do you think? I think it would be very challenging to be a worker. And those horses, ooh, they must have had to be strong. So much to learn about ice. So next time you take a look at your cup, maybe full of ice, before you drink something of your favorite beverage, think about where that came from. Most homes had an ice box. So here we're reading more about the history before we had refrigerators. Throughout the year, horse-drawn trucks carried blocks of ice to homes in towns and cities. The iceman used ice tongs to handle the heavy blocks. Ice blocks could range from 11 to 22 kilometers each. The iceman then used an ice pick to fit the block of ice inside the ice box. Children love to see the ice truck on hot summer days. I'm imagining like when you see the ice cream man today driving by in your neighborhood. That's what I'm imagining when the ice truck came into their neighborhoods. Not quite an ice cream truck, but an ice truck. They crowded around when the iceman pushed their door open. There was sure to be a sliver of ice for each of them. What a treat on a steamy day. So they were satisfied with a sliver of ice, little piece of ice. What would you? Would you be satisfied with that on a hot, steamy day? Header, why pipes burst? Pipes supply water to houses, schools, and other buildings. They are made of strong materials like plastic, copper, cast iron, and steel, but sometimes pipes burst. Do you know why? Water, like all other materials, contracts as it cools. But once the temperature gets down to 4 degrees Celsius, an amazing thing happens. So, water, in a way, contracts. You can think of all of it like pulling together. But then once it hits a certain degree, something else happens. As water continues to get colder, it starts to expand. Expand means to spread out between 4 degrees Celsius and 0 degrees Celsius. So, yes, we will be learning more about Celsius degrees and Fahrenheit and comparing them. But 0 degrees is freezing. So this is like all the freezing temperature. So when Fahrenheit, it's more around 32 degrees and 36 degrees on the thermometers that we use almost every day in Fahrenheit. That means the ice needs more space as it changes from liquid to solid. If liquid water completely fills a container, it will break the container when it freezes. So when we poured that water into our different cups, if we fill it all the way to the top and then we place it in the freezer, most likely that container will freeze. So it's important to leave room if you are going to freeze something in a container. Ice needs some room to expand or it will break its container. How can you prevent pipes from breaking in really cold weather? If the pipes are not used during the winter, drain the water out. If that is not possible, make sure pipes are all well insulated. Pipes can be wrapped with insulation or they can be buried deep underground. Another solution is to leave the tap open just a little bit. So that means like the handle of your faucet. You would just keep it open slightly for a little drop of water. Then the expanding water can push out the end of the pipe. The water might freeze in the pipe, but the pipe will not break. If the tap is closed, the water is trapped. Then something will break when the water freezes. Remember those icebergs in the northern and southern seas? So if you took a look at a globe, you would look at the top and the bottom. Why do they float? So think about those large chunks of ice. They're huge. How can they float in the sea? There is a connection between floating icebergs and breaking water pipes. Do you know what it is? Why do pipes break? Because water expands as it turns to ice. So take your arms and like spread them out. That's what water does when it turns to ice. The amount of water doesn't change. So I'm going to read that again. The amount of water doesn't change. So when you pour it into your cup, it stays that amount. But as it freezes, it spreads out. It's like it grows. If the mass stays the same, but the volume, the amount of space it takes up increases, the density of ice changes. If ice is less dense than liquid water, what will happen when you put ice in water? It floats. Now, yes, you're probably wondering about this word of dense, volume, mass. Oh dear, these are all very important words that we are going to investigate as we move forward in our science. The big word that I would like for you to remember is when water freezes, it expands. The word expands means to move away. We use it maybe for a synonym for spreading out. So I'd like you to remember that as we move to our next activity.